Welcome to U6L3 prisms. So a prism is a three-dimensional figure that consists of two identical parallel bases that are connected by rectangular faces. Okay, so we have two identical parallel bases, and then those are connected by, no matter what shape the bases are, rectangular faces. So all the faces are going to be rectangles. Now we're going to focus on specifically square prisms, rectangular prisms, and triangular prisms. You can have a base of any other type of polygon though, okay, like a pentagon or a hexagon or anything like that. But we're just going to focus on those ones. Those are the most common, okay? All right, so for example one, we're going to look at all four figures and we're going to identify the two bases and the height of the following prisms. Oh, and the height. So I forgot to mention that part. So the height is always going to be the distance between the two bases, no matter how the figure itself is oriented. Okay, so that's the height, the distance between the two bases. Okay, so we're going to identify the two bases, what shape they are, which ones are the bases, and then we're going to identify the height as well, and then we can name the prism based on its base shape. Okay, all right, so perfect. So first things first, if I look at my first prism here, notice that we have some solid dark lines and some like dashed lines, right? So just keep in mind with three-dimensional figures, the ones that are solid are the ones that you can see, and the ones that are dashed represent something that is either behind or below, something that you can't actually see, okay? Like if you were looking at it straight on. All right, so now it looks like we have two triangles, okay? I see two triangles, top and bottom. Those are going to be our bases. All right, so those are going to be the bases. So I'm going to go ahead and trace those. So both of my bases are triangles. Since the bases are triangles, then the name of the prism is based on that. So that is going to be a triangular prism. Okay, a triangular prism. And then the height is the distance between those two bases, okay? The distance between those two bases. So the distance between, for example, the triangle at the top and the triangle at the bottom, there's three different places that I can find that height, okay? So one would be here on the right-hand side, another would be the left-hand side, and the third would be on the back, right, that dash line. So I'm going to represent all three of those. I'm going to identify them as the height. So the right side, the left side, and that back length. Those are all going to be the height. So when you're actually working with things like 3D figures, they're generally going to just identify each of these distances in only one place. You just have to understand that they can be in any of those options, and those are all still the height. Okay. Second one, go to the right. So looking at this one, I can see, so the base is this one here at the bottom that has these segments labeled with tick marks, and it has the right angles, okay? So that looks like a rectangle down there. So that base is a rectangle. Okay, so I'm going to go ahead and trace that. That's a rectangle. So that base is a rectangle. The same base shows up here basically at the top is what it looks like. So that's going to be a rectangular prism. Rectangular prism. And that's because the bases are rectangles. Now, the distance between those two rectangles, okay, is going to be, there's four different places I can see it. So I can see it in the back right. Okay, that's height. I can also see it in the front. This is height as well here. Also the left part of the front, and also on the back here with this dashed line. So there's four different places that height could be labeled. All right, let's look at the last two. You might want to pause the video and try them out, and then watch the rest of the video. So for this one, the base looks like it's going to be this square at the back. I know it's a square, not a rectangle, because it has the same amount of tick marks on every side, right? It has one tick mark, meaning that those are all the same length. So that's a square. And then there's the same base on the front. That's kind of how it looks. So those are the bases. So that's a square. So that, since the base is a square, it's going to be a square prism. And then the distance between those two squares is the height, right? So the height is, for example, this short distance here. And there's three other places I can find the height. So at the bottom, behind on the bottom, and then at the top left. Last but not least, so looking at this one real quick, I can notice that there are actually two triangles. There's one on the front and then one on the back. And so those are going to be the bases of this prism. And since it's a triangle, it's also going to be a triangular prism, just like the first one was. And then the distance between is going to be this distance here at the top, okay, or the bottom left, which is behind, something you can't really see, and then the bottom right. Okay, perfect. All right, so now we're actually going to work with these prisms. So looking at the next page, we see SA of a prism. So SA stands for surface area, okay, surface area. And so surface area, just so we understand, is the area of every surface, right, or every face, every base of a prism. Okay, it's like if I were to cover a box completely with paper around the outside, right? It's just all the areas of all the faces added together. Of course, there's faster ways of calculating these things, okay? But that's really the idea, okay? And that's the surface area of any figure, really. It's just the area around the entire outside of that figure. So the surface area of a prism can be calculated using this formula. You take the base perimeter times the height, and then you add it to 2 times the base area. So whatever shape the base is, that's how we're going to determine the perimeter, the area. If it's a rectangle, it'll be slightly different than if it's a triangle, for example, right? And so you just have to be aware of what shape you're talking about, okay? And then here's the shorthand of how I write it. But of course, P is the base perimeter, H is the height of that prism, 2 is 2, and then B is the base area. Okay. All right. So example 2 says, find the surface area of each prism, identify the base and the height first, and draw the base separately. Perfect. Okay. So first things first, let me take a look at what I see here. So what I notice is that I have a prism that looks like either a square or rectangle. I can tell it's a rectangle because if I look at the base at the bottom here, it has the 3 right angles, and it has 9 by 11 feet as its dimensions, which is actually a rectangle, not a square, right? So I'm going to take that base, and I'm going to put that base over here. So I'm going to put a 9 by 11 rectangle. So 9 feet. Hold on, let me draw this a little neater. So take this base over here. So that's going to be 9 feet by 11 feet. Okay. 9 feet by 11 feet, and that's my base. So the base perimeter and base area are based on that figure itself. The height is going to be that distance between the 2 bases. Well, the other base is here at the top, so the distance between is going to be this 12 feet right here. That's going to be my height, okay? So I can write that down. So my height is 12 feet. Now we have this one. Now we need the perimeter of the base, and we also need the area of the base in order to actually calculate our surface area. So the perimeter of the base is going to be the perimeter of that rectangle. So we're going to add the 9 feet plus the 9 feet plus 11 feet plus 11 feet. And we are going to end up with 18 plus 22, which is going to be 40 feet. So the perimeter of that base is 40 feet. For the base area, it's a rectangle, so it's just going to be length times width. So it's going to be length times width, which is going to be 11. Which is going to be 11 times 9, which is 99, and then feet squared, because it's area, right? We're multiplying feet times feet. So now between those 3 values, I can plug that into my surface area equation. So the surface area is going to equal to the perimeter, 40 feet, times the height of 12 feet, plus 2 times the area of the base. Okay, B is the base area, 99 feet squared. Okay, now the feet are squared. The 99 is not squared, just to make sure you understand that. This means that feet squared is our unit. The 99 is not going to be squared. All you're going to do is do 99 times 2. Okay, so now we're going to have surface area equals. You can either do this by hand in steps, or you can do this in the calculator. If you do it in steps, you'll do 40 times 12 first, and you'll get 480, and it'll be feet squared because you're multiplying feet times feet. Okay, so that's going to be feet squared plus, and then 2 times 99, which is going to give us 198. Again, feet squared, that's our unit. And then just add those 2 values together, and you will get a surface area of 678 feet squared. Surface area is measured in the same units as regular area because it's just the same as the regular area of a 2-dimensional figure, but adding them all up for that 3-dimensional figure. All right, let's look at the next one. You might want to pause the video and try it out, see if you can do it. All right, first things first, we're going to figure out which is the base, and we're going to draw that separately. So it looks like, based on my right angles, I'm going to go ahead and go with those ones. So it looks like my base is that 6 by 6 square. Okay, and then I have the base at the back and I have it at the front as well. So I actually have the base twice. Okay, and that means that the height is going to be that distance between, which is going to be the 5 right there. Okay, all right, so let's draw our base over here. So let's draw this base over here. We just have a simple little square, 6 by 6, 6 feet by 6 feet. And then what we're going to do is we are going to find, we already found the height. The height is the 5 meters, right? The distance between the two bases. Now we just have to find our perimeter and our base area. So our perimeter is going to be adding 6 4 times, because you have these other two here as well, right? So 6 times 4, basically 24 meters. It's going to be our perimeter. And then our base area is going to be length times width again. But since it's a square, they're the same. So that's going to be 6 times 6. So that's going to be 36 meters squared. And then we're just going to substitute them into the same formula, okay? So we have surface area equals perimeter times height plus 2 times base area. Let's substitute everything in. So 24 meters for perimeter times 5 meters for height plus 2 times the 36 meters squared. So all I'm doing is substituting my values. Let's go ahead and simplify it. So 24 times 5 is going to give us 120 meters squared. Remember, every time you multiply meter times meter, you get meter squared. And then plus 72 meters squared. Add those together, and we're going to get 192 meters squared for our surface area for that square prism. Okay. All right, let's try this last surface area problem here for C. So first things first, taking a look, I can see that I have 2 triangles this time. So this is a triangular prism. So I have these 2 triangles. Oh, let me trace them in pink. So I have these 2 triangles at the top and the bottom, and those are my bases, okay? So those triangles are my base. So I'm going to go ahead and go over here. I'm going to draw a triangle. Now notice that this is a right triangle. It has a right angle here. So I'm going to draw that right triangle. It doesn't have to be perfect, just a quick little example. Now, I want you to note something else as well. So on the bottom base, for example, I see the right angle, and then I see that there's 4 feet at the bottom. Okay, so I can put that here. So that's 4 feet. But then the other dimensions, you actually have to look at the other base for them. So they didn't actually put the other dimensions here and here. They're actually at the top. So those dimensions are what we need to use here as well. Okay, they're not going to write them everywhere in the figure. They're just usually going to write them in one spot. So let's put our 5 feet here. That's our hypotenuse of that triangle. And then 3 feet on the right-hand side. So just make sure you're aware that a lot of times you do have to look in different locations to find all the dimensions. So that's our base. Okay, so this is our base. So when we find base perimeter and base area, that's what we use. For the height, it's going to be that distance between the two bases, which is this 6 feet over here. So our height is 6 feet for sure. Okay, so the perimeter is going to be the sum of 5, 3, and 4. So 4 plus 3 is 7, plus 5 is 12. So that's 12 feet. And then the base area, so the area of a triangle in general, right? Area of triangle is equal to base times height divided by 2. So that's the formula we're using here. So it's base times height divided by 2. But those are the base and height of the triangle itself. So how do I know it's the base and height of a triangle? It's the two that meet at a right angle. They have to be perpendicular. So we can call the base 4 of the triangle and the height 3 of the triangle, right? We're not going to use the 5 for the area. So that's going to be 4 feet times 3 feet and then divide by 2. So 12 divided by 2. So that's going to be 6 feet squared. Okay. Perfect. Okay, so now we plug everything in. So surface area is perimeter times height plus 2 times base area. 12 feet times 6 feet plus 2 times 6 feet squared. And now just work it out. If you want to type this in the calculator, just ignore the feet. You can actually type it in exactly as you see it. So you can do 12 parentheses 6 plus 2 parentheses 6 if you want to do it in the calculator. I'll show you what that looks like real quick. Here we go. So if you want to type it in like that, it'll work perfectly. Just ignore the feet for a second. Okay. And we're going to get 84 feet squared. remember, it's surface area, which is the same as area, so it's always measured in feet squared. So the surface area of that one is 84 feet squared. Perfect. Moving on. So now let's look at volume. So for the right-hand side, we are now looking at volume. Okay. Now volume, just so you understand, does not have anything to do with the outside of the figure, right? Volume is actually how much can the figure hold, right? It's the space inside of a three-dimensional figure. Okay. So this is the space inside. Let me write it like that, actually. Space inside. Okay, so that's what volume is. All right, so the volume of a prism is very simple. It's the base area times the height. Okay, it's even more simple than surface area. You just find the base area, multiply by the height, and you're done. Okay, keep in mind, because you're multiplying area times height, and area is a unit squared, and height is another unit of the same unit, say it's yards, then you're going to end up with something to the third power. So for example, if you have yards squared and you multiply by another yard, you're going to end up with yards cubed, or yards to the third power. Okay, so keep in mind that you're always going to have something to the third power here. Perfect. Okay, so find the volume of each prism. Identify the base and the height first and draw the base separately. So you start off the same way, except instead of finding perimeter, you only have to find base area and height and multiply them together. So it's a little bit simpler. Okay, so it looks like for the first one, I have a base here. It looks like it's kind of at the bottom, if you will, and it looks like a rectangle, a 10 by 12 kilometer rectangle. So my base is going to be a rectangle, 10 kilometers. Actually, I'll write it on this side, 10 kilometers by 12 kilometers. And then it looks like the height, the distance between those two is this 8 kilometers here. Okay, so the height is 8 kilometers. So the only thing you need to find this time is your base area and your height. So we already got the height, we just need to find the base area. Okay, so for the base area is just going to be length times width again, because this is a rectangle. So 12 kilometers times 10 kilometers. So that base area is going to be 120 kilometers squared. And then to find volume, very simple. It's just base area times height. So that's going to be 120 kilometers squared times the 8 kilometers for the height. And then multiply those together. I'm using my calculator to do it a little more quickly. And that's going to be 960. And since you're multiplying kilometers squared times kilometers, it's going to be kilometers to the third or kilometers cubed. And there's your volume. All right, let's try another one. So looking at this next one, B, it looks like once we look at it for a second, we can see that there's actually two triangular bases. Okay, so those are the bases. Let me go ahead and draw it separately over here. So I'm going to try to draw it kind of like it looks right now, just so I don't confuse myself. Okay, so I'm going to draw a dotted line with a right angle, just like it has there. It looks like that's going to be 8 centimeters right there. The bottom is going to be 10 centimeters. And then the other two dimensions, we do have to look at the base on top for those, the 10 and the 12. Okay, and I can put those here and here. Okay, so that's going to be 10 centimeters again, and then 12 centimeters. All right, perfect. So since this is volume, all we need is base area and height. So we have the base, we can find the base area. The height of the prism, if we go back, is the distance between those two bases, which is going to be this 9 centimeters here. So the height is 9 centimeters for sure. And then the area of the base, remember, that's only based on the base and the height of the triangle. So now this triangle has this right angle here. So the height is going to be this distance up through the triangle. So this is the height of the triangle. It's 8. So the height of the triangle is 8 centimeters. Okay. And then the base is going to be the side that is perpendicular to that, which is going to be this one where the 12 centimeter is. So that's the height of the triangle. Oh, excuse me, the base of the triangle. So the base of the triangle itself is going to be the 12 centimeters. So just remember, base and height of a triangle have to meet at a right angle. They have to be perpendicular. So it's going to be this 12 centimeter distance and this 8 centimeter distance. We can actually ignore these other two, 10 centimeters. Okay, so now we can find the base area. So the base area is going to be the base times height. So 12 centimeters. It doesn't matter which order you do it in, really. Times 8 centimeters divided by 2. So when we work that out in the calculator, 12 times 8 and then divide by 2, is 96 divided by 2, which is 48. So that's going to be 48 centimeters squared. And then to find the volume, you're just multiplying base area times height. So you're going to get the 48 centimeters squared times the 9 centimeters. And so that volume is going to be, I'm doing this in my calculator, 432. So 432 centimeters. And again, since you're multiplying squared times another centimeter, that's going to be to the third power, or cubed. Perfect. All right, you might want to try this last one. Pause the video, and then you can unpause and watch. Okay, so for C, I noticed that I have what looks like it looks like a square prism this time. So my base here at the back, which is what it kind of looks like to me, is 4 by 4. So my base, if I take it over here, it's just a little square, 4 by 4. So 4 kilometers by 4 kilometers. So that's my base. And then the height is the distance between those two, which is going to be this height here, this 11 kilometers. So the height is 11 kilometers. Perfect. So my base area is super easy for a square. It's just length times width, 4 times 4. So 4 kilometers times 4 kilometers. Sorry, hold on. Times 4 kilometers. It's going to be 16 kilometers squared. Perfect. And then just volume is just base area times height. So we're going to have for this volume 16 kilometers squared times 11 kilometers. And that's going to give us, I'm just going to do this with my calculator, make it faster. 16 times 11 is 176. 176. And that's going to be kilometers to the third power. All right, that's it for these notes. Thanks for watching. Have a great day.